We're going to do the same question now, but we're going to use a p-value method. And again, if you've forgotten what a p-value method is, then I'd really recommend going to look at the videos from Year 1 Statistics, and it's the last chapter on testing with the binomial distribution. So we're still going to look at the distribution of x bar under h0. So under h0, x bar follows a normal distribution with mean 60 and variance 3 squared over 16. We'd written that up here. So let's draw a sketch of this distribution. So we've got x bar along the horizontal axis, and we've got the distribution of x bar. In the middle, we've got 60. And for the p-value method, we still need to work out whether we're in the left 5% of the distribution to reject h0, because remember, we're looking for small values of x in order to reject h0. But this time we're going to say, well, I know that my x bar is 59.1. So let's put 59.1 on our diagram. So what we're going to do for the p-value method is we're going to work out what's the probability of being at 59.1 or to the left. So basically you can think of the p-value as being where you are or more extreme, and by extreme here we mean to the left because it's a left-tailed test, because we think x bar needs to be small. So let's work out what that probability is. So the probability of x bar being less than 59.1. And we're going to use our calculators to work out what this area is. And same as before with the critical region, we need to be really careful. We're doing it probability to do with x bar. So mu is going to be 60, and this is the variance of x bar. So this time we're going to go on distribution, normal, CD, and we want all of the area to the left of 59.1. So we're going to put our lower as a really, really small number, our upper as 59.1, because we want the area up to there. Now, same as last time, just as a reminder, the variance of x bar was this thing here. So your calculator wants the standard deviation, which is the square root of this fraction here, which is still 0.75. And under h0, mu is 60, because remember we're looking at what we're assuming h0 is true. And we get that as 0.115, or 11.5%. So that area there is 11.5%. So remember, we basically need to ask ourselves, are we in the left 5% of the distribution? Well, because we know the probability to the left of us is 11.5%, we know that we can say that 5%, our critical region, must be to the left of us. So that red area, 5%, must be to the left of us if we've got 11.5% to the left of us. So that means that we're not in the critical region. So we're not in the final 5%. So do not reject h0. And this time, in order to show the examiner that I know I'm not in the left 5%, I'm going to say that that's because 11.5% is greater than 5%. So just as a reminder, reject h0 if the p-value is less than the significance level. And if you've forgotten why that is, then look at the Year 1 Statistics video. This probability here is the definition of p-value. And we would have to do the same conclusion as we did with the critical region, but I'm not going to write that out again.